Let's look at 13. Look at vectors 2. So vectors 2, 13c. Okay, it says C intersects the y-axis twice. Okay, and what's the length of the curve? All right, guys, what's the formula for length of a curve? Let's do it. You just need to know the formula. S is equal to the integral of the square root of dx dt squared plus dy dt squared. Okay, question. Is this a dt or is this a dx? Okay, it is a dt, and that's super important. Because if this is a dt, then this is time 1 to time 2. So what you're trying to figure out is you've got this curve, and this curve intersects the y-axis 2 times, here and here. Okay? And if you want the length of the curve, then what you need to know is the time right here and the time right here. Is everybody good with that? So remember, you're just plotting. There's a bunch of plots, and there's a bunch of plots for time everywhere. Okay? But you want to know the time when it starts hitting the y-axis and the time when it ends, and that's the length of the curve that you need. All right, dx dt and dy dt, I'm going to assume that that's pretty easy, right? You know what that is. Is it given somewhere in the problem? Yeah? Okay, so all you need to know is when the time, what these times are. Okay, so guys, how do I find these 2 times? It's when what? It's when x is equal to 0. You guys good with that? So you must have some equation somewhere where x is equal to something. We have x is equal to 2 minus 3 cosine t, 2 minus 3 cosine t. So what you're going to do is you need the time when x is equal to 0, because whatever this point is, it's I don't know, it's 0, 5, let's say, or this point here is going to be 0, negative 1. Does that make sense? Every point on the y intercept has an x value of equal to 0. Try it. Try any point. Okay, it's always going to be 0 something. So it's actually not 0, 5, or 0, negative 1. Okay, so then what we're going to do is we're going to come up here and we're going to put a 0 there. Okay, so this would be cosine t is equal to 2/3. Is that right? So you ask yourself the question, this t right here, when it sits next to the trig function, it's an angle. So you're asking yourself, at what angle is my cosine value 2/3? Okay, and nobody knows. Okay, I mean, you shouldn't know because it's not really part of your unit circle. So then you just go to your handy dandy calculator, okay, and you say, what cosine value is this 2/3? Try to think what the easiest way to do it. Just do an arc cosine, I guess. So if we do an arc cosine, second cosine of 2 divided by 3. Okay. Remember, that whatever I get, it's going to be an angle. Is everybody good with that? And do you agree it's going to be a radians, right? Because I'm in radian mode. And so this angle is going to be 0.841. So what does that mean? That means from this 0, if I go up 0.841, okay, that will be a cosine value of 2/3. You know, 2/3 is positive, so that makes sense, right? Right here, your cosine value is 1. Here, your cosine is less than 1. Okay. Remember, right here, if I went all the way up, I'd be at 90 degrees, right? So 90 degrees is pi over 2, which is about 1 point something, right? So 0.8 shouldn't get to 1 point something. Okay, it should be an angle less than 1 point something. All right, so 0.8 is right there. So I need another value for time. Okay, one time is 0.841, so this could be, I don't know actually. One is 0.841, I don't know which one. But I need another angle. Go look at 13. What did they say t had to be between? Negative pi over 2 and pi over 2. So guys, if I go between negative pi over 2 and pi over 2, where's my other angle that I'm going to have a 2/3 cosine value? Remember, cosine value is your x value right here, right? So what I'm going to do is I'm going to find this one right here. Okay, so I'm looking for this angle right here. If this is 0.841, then what's this angle? Negative 0.841. Okay, so that's how unit circles work, right? Like if this were 30 degrees, then this would be negative 30 degrees to have the same x value here. So right here, you're going to put negative 0.841 here and positive 0.841 here. And then everything else, I think you would just, I think you're good on the rest of this. Okay, what other questions do you guys have? is going good. Yes. Yes, Harlan. Number 2 on worksheet 1 or 2? Worksheet 2. Number 2, worksheet 2? Okay. Look at number 2, guys, worksheet 2. So, length of the path. Okay, so you want length of a path. What's the formula for length of a path? All formulas. What's the formula for length of a path? Length of a integral of square root dx dt squared plus dy dt squared. Okay, you'd only use this formula though if you have parametric. Do you have a t in your formulas? Yes. Okay, then you'll use this formula. If you don't have a t, you use the other 1 plus f prime. Do you remember that? Okay, this formula, is it a dx formula or is it a dt formula? Okay, it is a dt, so that means this must be t1 to t2. I think you just plug in. Okay, now this derivative is a little bit tricky, so let's do this derivative. Cosine cube. So if x is equal to cosine cube t, okay, what is dx equal to? Be very careful. This one's tricky, and actually, I would put a star by this. This little derivative, lots of students miss it on the test, okay? This is actually equal to, this 3 is really, I think, disrespectful to students, okay? Because it's not really, I mean, students don't know what to do with this 3. This 3 really belongs on the outside here, okay? So when you take the derivative of this, the dx dt, it is a chain rule. So it is 3 times the quantity cosine t. Take this down by 1 power, but guess what else you have to do? Take the derivative of cosine. What's the derivative of cosine? Negative sine t. So this is actually equal to negative 3 sine t cosine t squared. Okay, you would stick this whole thing, wow, into there. And then you'd have to square this. Okay, so when you square this, when you have dx dt quantity squared, negative 3 squared is going to be 9, sine squared is just going to be sine squared, and cosine t to the square is now 4. Everybody good with that? So it's a little tricky, and I think the dy dt might be a little bit tricky too. So just be careful on that chain rule. Okay? All right, what other questions do you guys have? Wait, am I good on that? If I showed you that, is that good enough? They would just put that into your calculator, I think, and you should just punch out an answer. Okay? This problem on your test will be set it up. Take the derivative, set it up. Let me see what your final setup will be. Okay, and so many students do the inside here incorrectly, so be careful on that. All right? Okay, yes, David?
How far do you want to do this?
I think I'm pretty flexible on your test. I think if you stop here and push it in, then you're good. Most students miss it right here. So, okay. What other questions do you guys have? Yeah. Number 6. Yeah, a lot of students, this is 6 on worksheet 2, right? Yeah, a lot of students had questions on this one. So let's look at 6 worksheet 2. And when I do it, you'll be like, oh, because I think you could make it really hard, but you could also make it really easy. All they're saying is get rid of the t parameter. Okay, you could solve for x or solve for y, it doesn't matter, but get rid of the t parameter. So I'm going to let you guide me here. Which one do you want to solve for t first? Okay, so if I solve for t first, what I'm going to do is I'm going to move this over. And this problem, guys, is really all algebra. Okay, there's not, actually, I don't even think there's any calculus in there. There's no derivatives or limits or integrals. It's just a tougher calculus, tougher algebra than you're used to. Okay, guys, all I need to do is, if I know this is ET, all I need to do is see that this has an ET in it, right? Isn't this really just y equals 2 times ET squared, right? Well, if there's an ET here and there's an ET here, isn't this really just equal to y equals to 2 times, what's my ET? X minus 1 quantity squared, and that's it. That's it. Okay? Some of you guys might have done other things. This is the easiest way to do it. You could have taken the log of both sides, but after you took the log, then you had to E it again to plug it back in here. Okay, so just FYI. This was the easiest way to do it. All right, what other questions did you have? You good? Okay, so make sure you're comfortable with these vectors. I don't think it's very hard if you practice and you know the formulas, okay? But if you haven't practiced, and you don't know your formulas, it's going to be super hard, right? Please pull out your, this worksheet right here, this guided notes right now for polar.